Okay, we are doing lesson 39 in Algebra 1. Okay, we're going to talk about trichotomy axiom. It's just a big word. So let's look at this example. It says Johnny wrote a number on a piece of paper. Then he turned the paper over and wrote a number on the other side. So there's exactly three possibilities. Either the second number is less than the first, the second number is the same as the first, or the second number is greater than the first. Well, this seems pretty obvious. Mathematicians see that this is really significant and this property of real numbers, which will help us later on, and they call this trichotomy axiom. Axiom just means property or rule. So if you look at the box middle of 39.8, you'll see this trichotomy axiom, and you need to know what this means and how to explain this. Basically, it says for any two real numbers, a and b, exactly one of the following is true. Either a is going to be less than b, a is equal to b, or a is greater than b. And that's basically all that rule says, and it goes back to our little example. Johnny wrote a number on the front, a number on the back. It's either the first number is less than the second one, it's equal to the second, or it's greater than the second one. So you need to write this down in your notes and have it ready so when you go back to do a test or a quiz or you're studying, you can use this to study. Let's look at symbols of inequality that are negated. We can always say, when you use an equal sign, we can say 3 is not equal to 10, right? Or we can say 3 is equal to 3. And we use this slash sign to say it's not equal, to make that a true statement. Well, we can do the same thing for inequalities. Remember, inequality is a greater than or less than, greater than, equal to, or less than, equal to sign. So if I say x is not greater than 10, when I put that, basically what I'm saying is, oops, x, not a. I'm saying x is less than or equal to 10. Remember, we said a is less than b, a is equal to b, or a is greater than b. When we say a is not greater than b, what are we left with? A is equal to, or a is less than. That's why we get this. So these two statements say the same thing, they just look different. And the way you want to think of it, remember when we said 3 is less than 4, we can also say 4 is greater than 3. They look different, but they mean the exact same thing. You read from left to right. So this says x is not greater than 10. So if you look at the three examples, if it's not this one, then it's one of these two. So then you can flip it and say x is less than or equal to 10. So let's look at another example. Let's look at x is not greater than or equal to 6. Okay, again, let me write these down. Okay, so we said x is not greater than 6 and x is not equal to 6. So to make another way to write this statement is to say x is less than 6. Because remember we said there's three possibilities, there's exactly only one. Alright, so let's look at example 39.2. It says draw a number line to graph the solution x is not equal to 2. So you draw your number line. Okay, well, because it's a negated solution, we said it's not less than, it's not this one, so it has to be this one or this one, which means x is greater than or equal to 2. So we have to go do that. 3, 4, 5. So we find 2, because it's got the equal sign, we color in our bubble, and then we do this. Alrighty? Pretty simple. So now let's look at the next example. And it helps if you write this down over here. This is your rule, or trichotomy axiom property. So it says, write both an inequality and a negated inequality to describe this graph. So our graph is let's see. So our graph looks like open circle this way. Okay, so basically this graph says x is to the left of 3, so it's less than 3. So the negated, so it's x less than 3. These are the negated ones. So to change this to negated, say x is not greater than or equal to 3. So you have to write, this is the inequality to this graph, and this is the negated inequality. So we're saying it's x is not greater than or equal to 3, because x is not there. We're saying x is less than 3. So we start off by writing the inequality of this graph. X is less than 3. So you come over here to your three options, say if I got this, then these have to be my negated, so I have to say x is not greater than or equal to. And that's how you write it. Okay, now let's look at, moving along a little bit further, let's look at some advanced ratio problems. We just talked about ratio. So if I were to tell you the ratio of red marbles to blue marbles is equal to 5 to 7, pretty simple. Now we told there's a total of 156 marbles and we're asked to find how many red marbles. We're like, what do we do? Well, if you look at the middle, and I'm going to go by what they're saying, but I'm going to go back and teach you a couple different other options. It says first you have to write the information given, which we said there's red, there's 5, blue, there's 7, and in total there's 12, right? 5 plus 7 is 12. And then we use the cover-up method to write 3 equations. So basically what they're saying is you're going to do this and say b to t equals 7 to 12. Cover up the middle one and say r to t equals 5 to 12. Cover up this one and say r to b is equal to 5 to 7. Then we go back and look at what are they asking for. And clearly they said, here it says, now we read the question, it says there are 156 total, and after how many red marbles? So we need red t. So we need this one, so we would do r to t equals 5 to 12, and we don't know how many red, but they said there's 156 total. So now we have our 5 to 12 equals r to 156, and we simply cross multiply 156 times 5 equals 12r. When we multiply that, we will then divide by 12, and we'll get r, and I'm going to cheat here, equals 65. Okay, and you're like, that's a little confusing. It is a little confusing that way, but you can write what they gave you, cover up and write, cover the first one, say b to t is 7 to 12. Cover up the second one, r to t is 5 to 12. Cover up the third one, r to b is 5 to 7. Then we say, okay, they said we have 156 total. How many red? So we need an r to t or t to r, and we have it right here. So we would use this one, and you would say r we don't know, t we know. Another way of looking at this is we'll do another example and do it the different. Let's look at example 39.4. So the ratio of fish to crab in the sea cave was 13 to 4. Okay, and it says if there were 119 fish, keep them the same. Oh, 119 fish and crabs. So that means this plus this. So we need a total. We can do, right, 13 plus 14. So there's 119 fish and crab in the sea cave. How many were fish? This is what we want. So we can do, we look at our columns and say, okay, they want this. I know I have to have this. to this. Can I do it to this? Can I do it fish to crab? Well, if I do fish to crab, guess what? I have two unknowns. That's not going to help me. But if I do fish to total, I only have one unknown. So then I can do F to T, but you got to keep them in the same column. So 13 fish to 17 total. We don't know how many fish, but we know there's 119 total. So then you have 13 over 17 equals F to 119, and you do your cross multiplication. 13 times 119 equals 17 over F, divided by 17. Again, I'm going to cheat and use the book to find that out for you. And you get F equals 91. Now, if you needed to go back and find how many crabs, you could do crab to total, these two to these two. Or, what do I know? I know this plus this has to equal to that, so I could simply do 119 minus 91, and this would be 28. But I had to make sure that I didn't divide or multiply incorrectly, or I didn't set this up wrong, because if I set it up wrong, it's going to give me an incorrect answer here, which would cause this to do incorrectly if you use this method instead of the crab to total equals 4 to 17 equals C to 119. Okay? So those are two different ways of looking at it. So do your practice problems, and the code for this lesson is 850, the number 850, 850 at the top of lesson 38.